Civil engineering is more than just concrete and steel. It's about people. It's about protecting their safety and well-being. Ethics are at the core of this responsibility. They guide engineers to design and build structures that are safe, reliable, and beneficial to society. Trust is paramount in this profession. The public needs to know that engineers are working with their best interests at heart. Ethical breaches can have devastating consequences. Collapses, accidents, and failures often stem from a lack of ethical conduct. These events not only result in physical damage, but also erode public trust in the profession. This trust, once broken, is difficult to rebuild. Ethical engineering is not just about avoiding disasters. It's also about creating a sustainable future. Engineers must consider the environmental impact of their projects. They must strive to minimize waste, reduce carbon footprints, and protect natural resources. Ultimately, ethical engineering is about making responsible decisions. It's about putting people and the planet first. By upholding the highest ethical standards, civil engineers can shape a better and safer world for generations to come. The history of civil engineering is marked by both triumphs and tragedies. Failures, while unfortunate, offer invaluable lessons. They highlight the critical importance of ethical design, construction, and maintenance. The collapse of the Hyatt Regency Walkway in 1981 is a stark reminder of the human cost of ethical lapses. Design flaws and communication breakdowns led to this disaster, killing 114 people. The tragedy prompted significant changes in engineering codes and practices. The Chernobyl disaster in 1986 underscores the need for transparency and accountability. Design flaws and human error had far-reaching consequences. It serves as a reminder of the global impact of engineering decisions. The Rana Plaza collapse in 2013 highlighted the ethical responsibility of engineers. Structural issues and lack of oversight led to this tragedy. It underscored the need for ethical sourcing and fair labor practices. These tragedies remind us of the importance of ethical conduct in civil engineering. They highlight the need for constant vigilance and a commitment to safety. The digital age has revolutionized civil engineering, offering powerful tools for design, analysis, and construction. Building information modeling, artificial intelligence, and data analytics are transforming the field. However, these advancements also present new ethical challenges. Data security is paramount in the digital age. Engineers must ensure the confidentiality and integrity of sensitive project information. Cyber attacks and data breaches can have severe consequences, compromising safety and eroding public trust. The rise of AI in engineering raises concerns about bias and accountability. Algorithms are only as good as the data they are trained on. Biased data can lead to discriminatory outcomes in infrastructure design and decision-making. Engineers must be aware of these biases and work to mitigate them. The increasing reliance on automation raises questions about human oversight and responsibility. While automation can improve efficiency and accuracy, it should not replace human judgment and ethical decision-making. Engineers must remain accountable for the outcomes of their work, even when using automated systems. As technology continues to evolve, it is crucial for civil engineers to navigate these digital dilemmas ethically. This requires a commitment to responsible data management, awareness of AI biases, and maintaining human oversight in an increasingly automated world. Ethical dilemmas are rarely clear-cut. Engineers often face complex situations with competing priorities and potential conflicts of interest. Navigating these gray areas requires a strong ethical compass and a systematic approach to decision-making. One framework for ethical decision-making involves identifying the relevant moral principles at stake. These may include honesty, integrity, fairness, and responsibility. Once these principles are identified, engineers can evaluate potential courses of action and their likely consequences. Seeking diverse perspectives is crucial in ethical decision-making. Consulting with colleagues, mentors, and professional organizations can provide valuable insights and help identify blind spots. Engineers should be open to different viewpoints and be willing to reconsider their own positions. Transparency and documentation are essential throughout the decision-making process. Engineers should clearly communicate their rationale for decisions, especially when ethical considerations are involved. This documentation can be invaluable in the event of future inquiries or disputes. Ultimately, ethical decision-making is an ongoing process of reflection and learning. Engineers should strive to learn from their experiences, both successes and mistakes, and continually refine their ethical compass. Section 5. The ASCE Code of Ethics, a guiding compass. The ASCE Code of Ethics guides ethical conduct in civil engineering. It outlines core values and principles for behavior. Key principles include public safety, integrity, and honesty. It stresses lifelong learning and professional development. The code is a living document reflecting evolving ethics. By adhering to it, engineers uphold the profession's integrity. Section 6. The power of community professional organizations. Professional organizations, such as the ASCE, play a vital role in upholding ethical standards in civil engineering. These organizations provide a platform for professional development, networking, and ethical guidance. Professional organizations offer continuing education courses and workshops that address ethical issues. These programs help engineers stay abreast of current ethical challenges and best practices. They also provide opportunities for engineers to share their experiences and learn from one another. Many professional organizations have ethics committees or hotlines that provide guidance and support to engineers facing ethical dilemmas. These resources offer a confidential space for engineers to seek advice and discuss challenging situations. Professional organizations also play a role in advocating for ethical practices within the industry and society at large. They may develop position statements on emerging ethical issues, engage in public outreach, and work with policymakers to shape regulations and standards. By actively participating in professional organizations, civil engineers can contribute to a culture of ethics within the field and work collaboratively to address the ethical challenges of the 21st century. Section 7. Education and training nurturing ethical engineers. Ethical conduct is not innate, it is cultivated through education, training, and mentorship. Instilling ethical values in future generations of civil engineers is crucial for the long-term integrity and sustainability of the profession. Ethics education should be an integral part of civil engineering curricula. Courses on engineering ethics can introduce students to ethical theories, decision-making frameworks, and case studies of ethical dilemmas. These courses should encourage critical thinking, moral reasoning, and the development of a strong ethical compass. Practical ethics training should complement theoretical coursework. Internships, co-op programs, and research experiences provide students with real-world exposure to ethical challenges. Mentorship from experienced engineers is invaluable in guiding students as they navigate the complexities of ethical decision-making. Universities and engineering schools have a responsibility to foster a culture of ethics that extends beyond the classroom. This includes promoting academic integrity, encouraging ethical research practices, and modeling ethical behavior among faculty and staff. By equipping aspiring engineers with a strong ethical foundation, the profession can ensure that future generations are prepared to tackle the ethical challenges of an increasingly complex world. Section 8. Building a better future ethics in emerging technologies. Emerging technologies such as artificial intelligence, big data, and autonomous systems are poised to transform the field of civil engineering. While these technologies offer tremendous potential for innovation and progress, they also raise novel ethical considerations. As AI plays an increasingly prominent role in infrastructure design and decision-making, it is crucial to address the potential for bias in algorithms. Engineers must ensure that AI systems are trained on diverse and representative data sets to avoid perpetuating existing inequalities. The use of big data in civil engineering raises concerns about privacy and data security. Engineers must handle sensitive personal information responsibly and transparently. Clear guidelines and regulations are needed to govern data collection, storage, and use. The development of autonomous construction equipment and infrastructure systems raises questions about liability and accountability. Engineers must carefully consider the ethical implications of delegating decision-making authority to machines and establish clear lines of responsibility. As we embrace the potential of emerging technologies, we must do so ethically and responsibly. This requires ongoing dialogue, collaboration, and a commitment to ensuring that these technologies benefit all members of society. Section 9. A collective responsibility shaping tomorrow's world. Ethics in civil engineering is a collective responsibility shared by practitioners, educators, organizations, and society. Engineers must uphold ethical standards, advocate for ethical practices, and hold each other accountable. Educators must instill a strong ethical foundation in future engineers. Professional organizations provide ethical guidance and promote development. Policymakers must establish clear ethical guidelines for technologies. The public must demand ethical conduct and support sustainable projects. Together, we can create a future where civil engineering improves life for all.